Hello, my name is Pejman. I'm a postdoctoral researcher at the Center for Immersive Experiences at the Pennsylvania State University. In this presentation, I will be talking about an experiment that explores the influence of different types of head-mounted displays and individual differences among learners in light of spatial ability on the experiences and learning of individuals in immersive place-based education. To frame our research, I'll refer to the sensatium continuum that we have proposed in our previous works. This continuum, which ranges from conventional desktop displays at the lowest end of the sensing but the highest end of scalability, to, for example, the HTC Vive Pro with eye and body tracking at the highest end of sensing but the lowest end of scalability, demonstrates the associated trade-off of different VR technologies. Evidently, greater sensing can result in the production of richer and more interactive experiences. However, it is also associated with considerable cost in terms of developer time and necessary equipment such as high-end displays, VR-ready computers, and sensors which reduce scalability, particularly in relation to conducting evaluations with medium to large-size populations, as well as mass dissemination in classrooms. As such, one of the pertinent questions in the immersive learning research domain is to what extent the associated attributes of different displays affect their applicability in education. Do the superior tracking and sensing of high-end displays justify their shortcomings in scalability and mass dissemination in educational settings or not? To investigate this question, we have explored the scalability and applicability of two different VR displays, namely Oculus Quest and HTC Vive Pro, in an educational immersive virtual field trip based on 360-degree imagery that focuses on geoscience education. Although there are similarities in terms of sensing capabilities between the two displays under study here, they are still different in display resolution, frame rate, and field of view. But more importantly, the Oculus Quest is a standalone display which does not require a VR-ready computer and is considerably cheaper than an HTC Vive Pro. This places the Quest closer to the high end of the sensatium scalability spectrum compared to the Vive Pro. In light of this, we argue for the importance of investigating whether a standalone and scalable display, i.e. Oculus Quest, can replace a high-end one, i.e. HTC Vive Pro, particularly in educational settings such as classrooms. A total of 45 students participated in this study. Of these, 30 students went through the learning experience using the Oculus Quest and 15 using the HTC Vive Pro head-mounted display. All students were recruited from a geoscience class at the Pennsylvania State University. Furthermore, the experiences and learning of the participants were assessed using self-reported questionnaires based on the metrics listed on this slide. The immersive virtual field trip used in this research takes the students to the Ritzville and Bald Eagle formations in central Pennsylvania as part of an introductory geoscience course at the Pennsylvania State University. The experience is based on 360-degree high-resolution images, high-resolution outcrop photos, diagrams, and a 3D model of part of the outcrop built using a structure from motion. The entire experience is narrated with audio clips that explain the specific features of the outcrop and/or the tasks learners need to perform as they navigate between the 360-degree images in a predefined sequence. Going beyond the comparison of two displays, we are also exploring how the individual differences among learners in terms of spatial abilities can affect their experiences and learning in immersive place-based education. Place-based learning requires a good degree of spatial ability on the learner's part. Compared to desktop experiences, immersive ones perceived through head-mounted displays more closely resemble actual field trips. Therefore, one can argue that the spatial abilities of learners can affect their learning and general experiences in educational interventions that focus on place-based learning. However, not much is known about whether the spatial abilities of learners can determine their learning outcome and experience in this novel educational medium. We have explored this topic in light of a student's sense of direction, or SOD, as an indicator of their large-scale spatial abilities. Our results indicate that participants in the Quest condition reported higher levels of simulator sickness and satisfaction compared to the Vive Pro condition. Considering that the other experiences and learning metrics of participants were not significantly different between the two conditions, our results suggest that the Oculus Quest can be considered as a viable and cost-effective replacement for learning via immersive virtual field trips. Our findings have important implications in the academic research domain and for classroom education with VR technology. The logistics of administering a VR experience in a classroom using the Vive Pro is significantly more complicated for both the educators and researchers as well as the students. Evidently, a headset that requires a VR-ready computer cannot be easily transported into lab sessions or classrooms, which leads to requiring the students to go to a VR lab instead. Although a minor inconvenience on the student's part, this extra level of requirement could introduce a negative effect on the satisfaction level of the students with the educational experience as a whole. With respect to simulator sickness, although the average means are low for both conditions, we have observed a higher and significant score in the Quest condition. This could be due to the inferiority in the display resolution, frame rate, and the field of view of the Quest compared to the Vive Pro. Such inferiority might manifest itself in the perception of the 360-degree images and the 3D models of the outcrop used for the activities performed by the students. There is a division of opinion in the literature on whether the head-mounted display type actually affects the experiences of learners. Our results indicate that such differences do exist. Therefore, our results not only pertain to the quality comparison of displays, but are also relevant and important in understanding the potential of standalone head-mounted displays in large-scale classroom applications. Given the large sample size in the Quest condition, we explored the effect of individuals' spatial ability, i.e. sense of direction or SOD, using only the results from the Quest participants. We performed the median split to convert the numeric scores into two categories, low SOD and high SOD participants. Our results showed that high SOD participants reported significantly higher spatial situation model and self-location scores than low SOD participants. With respect to the learning metrics, high SOD participants reported significantly higher perceived usefulness, reflective thinking, and perceived learning effectiveness than low SOD participants. As such, our results suggest that individual differences between learners can be a significant determinant of their experiences and learning in immersive virtual field trips. It is important to note that we have not measured the learning outcome or performance of participants in the context of this study and therefore cannot draw any conclusions on whether low SOD participants have learned the same from the virtual field trip compared to the high SOD ones. Notwithstanding, our findings indicate that the spatial abilities of learners are important factors to be considered in the design of immersive virtual field trips. Our findings are important in understanding the potential of standalone head-mounted displays in large-scale classroom applications, highlighting that the standalone and scalable head-mounted displays seem to cause higher levels of satisfaction in users than high-end tethered ones, probably mostly due to practical advantages. Our study has highlighted the importance of scalability in large-scale classroom user studies. Data collection with high-end head-mounted displays is associated with higher costs, not only in terms of equipment, but also time, since evaluations need to be performed with one participant at a time. These logistical challenges further demonstrate the advantages of scalable head-mounted displays. Furthermore, although we cannot draw any conclusions on whether low SOD participants have learned the same from the virtual field trip compared to the high SOD ones, we saw that the spatial ability is an important learner characteristic that should be considered in the design of immersive virtual field trips. This opens the door for numerous interesting research questions related to the design of immersive experiences with the objective of catering to both high and low spatial ability learners. Thank you very much for your attention. If you have any inquiries, please write to the email address mentioned on this slide.